Welcome to S&P Knowledge Series. In this episode, let's discuss on the topic Building the Future, how Agile construction transforms projects from concept to completion, authored by Mr. S.N. Panigrahi. Agile methodology is a flexible, iterative, and customer-focused approach to project management that delivers small, valuable increments quickly while adapting to change. It emphasizes collaboration, transparency, continuous feedback, and empowered teams to ensure high-value outcomes. By integrating lean principles, risk reduction, and continuous improvement, Agile drives faster delivery, efficiency, and adaptability across industries. Agile is increasingly being used in construction as projects face uncertainty, changing client needs, and complex stakeholder coordination. Instead of rigid plans, Agile brings flexibility, collaboration, and faster value delivery. Agile construction represents a paradigm shift from traditional waterfall project management to iterative, collaborative approaches that emphasize flexibility, continuous improvement, and stakeholder engagement throughout the construction lifecycle. The 4 values of the Agile Manifesto. First value, people and interactions over processes and tools. While construction inevitably involves complex processes and specialized tools, Agile construction prioritizes human collaboration. Daily stand-up meetings between architects, contractors, and subcontractors ensure everyone understands current priorities and obstacles, fostering problem-solving through direct communication rather than formal procedures. Second value, completed and usable construction components over comprehensive documentation. The focus is delivering usable physical value. For example, a finished floor, an operational HVAC system, a functional hospital wing is more important than drowning in endless drawings, approvals, or documentation. Documentation is not eliminated, but minimized to the just enough level to ensure compliance, safety, and communication. Example: instead of waiting for full design documentation of an entire hospital, Agile teams deliver a ready-to-use outpatient wing first, getting client feedback, then iterating on the rest. Agile value 3. Collaborative planning over rigid contract enforcement. Traditional construction depends on rigid upfront planning, extensive documentation, and negotiated contracts, leaving little room for flexibility once execution begins. Agile construction emphasizes collaborative planning and continuous engagement with owners, architects, contractors, and users throughout the project, not just what was locked in at the contract stage. For example, instead of spending months creating perfect architectural drawings, teams might develop minimum viable designs that can be refined through regular feedback loops with clients, contractors, and end users. Fourth value of Agile: responding to change over following a plan. That is adaptive response over change resistance. Traditional construction treats changes as expensive disruptions requiring formal change orders and approvals. The Agile team has autonomy to adopt changes. Agile construction builds change management into the process through regular sprint reviews and retrospectives. When a client realizes they need additional power outlets in a conference room, Agile teams can incorporate this change in the next iteration rather than treating it as a costly deviation. Agile core principles. Agile principles emphasize customer satisfaction through early, continuous delivery, welcoming change, and delivering value in short cycles. Agile construction emphasizes iterative delivery over big bang completion to ensure customer satisfaction. Rather than delivering entire buildings at once, Agile construction breaks projects into smaller, functional components that can be completed and handed over incrementally. A commercial office building might be delivered floor by floor, allowing tenants to move in and provide feedback while upper floors are still under construction. Teams work collaboratively, transparently, and sustainably, empowered to self-organize, with frequent reflection to improve. The focus remains on simplicity, technical excellence, and adaptability, ensuring working solutions drive progress over exhaustive documentation. Agile Construction Framework. Agile Construction Framework, Sprint Planning and Execution. Agile construction projects are organized into time-boxed sprints, typically 2-4 weeks depending on project complexity. Each sprint focuses on delivering specific, measurable outcomes. For a residential development, one sprint might focus on foundation and utilities for 3 houses, while the next sprint tackles framing and roofing for the same units. Cross-functional teams. Agile construction teams integrate architects, engineers, contractors, and key subcontractors from project inception. This eliminates the traditional handoff delays where architects complete designs before engineers begin structural analysis, which then goes to contractors for pricing and constructability review. Instead, all disciplines work concurrently, identifying potential issues early and optimizing designs collaboratively. Continuous integration and testing. Quality assurance happens throughout construction rather than at final inspection. Teams implement continuous testing protocols, conducting regular quality checks at each phase completion. For example, electrical rough-in might be tested and approved before drywall installation begins, preventing costly rework if problems are discovered later. Stakeholder feedback loops. Regular reviews with clients, end users, and regulatory authorities ensure the project stays aligned with expectations and requirements. A hospital construction project might include monthly walkthroughs with medical staff to validate room layouts and workflow patterns, allowing adjustments before final finishes are installed. Implementation methodologies. Last Planner System Integration. The Last Planner System, developed by the Lean Construction Institute, aligns naturally with Agile principles. Weekly work planning sessions involve all trade contractors committing to specific deliverables, similar to Agile sprint commitments. Constraints are identified and resolved proactively, and work is only scheduled when teams have high confidence in completion. Building Information Modeling, BIM, as Agile infrastructure. BIM platforms serve as the digital backbone for Agile construction, enabling real-time collaboration and rapid iteration. When the mechanical engineer identifies a conflict with structural elements, the entire team can visualize the issue immediately and collaboratively develop solutions without waiting for formal drawing revisions. Agile also adopted lean practices. Lean construction principles. Waste elimination, continuous flow, and pull-based scheduling support Agile objectives. Just-in-time material delivery reduces storage costs and damage, while pull scheduling ensures work progresses based on downstream readiness rather than arbitrary timelines. Agile construction workflow. Step 1. Define value. What does the client need first? For example, parking structure before office interiors. Step 2. Break down project, create backlog, list of deliverables. Step 3. Plan sprints, 2 to 4 week cycles focusing on specific deliverables. Step 4. Execute and review, daily huddles, weekly reviews, stakeholder demos. Step 5. Deliver incrementally, hand over completed usable sections early. Step 6. Reflect and improve, retrospectives to improve next sprint. Tools and technologies supporting Agile construction. Digital collaboration platforms, Procore, Autodesk BIM 360, PlanGrid. Building information modeling, BIM, enables real-time design changes. Virtual design and construction, VDC, simulations before execution. Drones and IoT sensors provide live progress data for adaptive planning. Kanban Scrum software, Jira, Trello Mississippi Project Agile. Benefits of Agile construction. Time savings, early deliveries, faster adaptations. Case: a construction company cut project delivery substantially using Agile plus BIM. Cost control, reduced rework and overruns. Example: lean pull planning reduced waste substantially on a hospital project. Improved quality, continuous feedback ensures fewer defects. Stakeholder alignment. Owners, designers, and contractors stay aligned. Risk reduction. Adjust to supply chain logistics challenges dynamically. Real-world examples. Heathrow Terminal 5, UK, used collaborative planning plus agile practices to manage 200+ contractors delivering different packages, architecture, engineering, systems, retail, baggage handling. Used short planning cycles and continuous feedback loops. Used last planner system, lean construction, a form of collaborative scheduling, allowing real-time adjustment of contractor tasks. DPR Construction, USA, has successfully applied Scrum and Lean Agile practices in hospital construction projects, delivered operating rooms earlier than scheduled with improved coordination among trade partners, increased reliability of commitments, reduced rework, and faster decision-making. Crossrail, Elizabeth Line, UK, applied Agile principles plus BIM, building information modeling, for managing its massive rail system integration. BIM enabled a common data environment for 30+ contractors, ensuring clash detection and design coordination. Agile methods, short sprints, iterative testing, were used for rail systems integration, signaling, power, safety. Practical examples and case studies. Modular construction excellence. A technology company headquarters utilized agile construction principles by prefabricating office modules off-site, while site preparation occurred simultaneously. Each module was designed as a minimum viable workspace that could function independently. As modules were installed, employees moved in and provided feedback that influenced the design of subsequent modules. The result was a 40% reduction in overall project timeline and higher user satisfaction scores. Second case, healthcare facility adaptation. During construction of a medical clinic, regulatory requirements changed regarding infection control protocols. Traditional construction would have required expensive change orders and scheduled delays. The Agile team had built flexibility into their sprint planning, maintaining buffer time and modular design approaches that allowed rapid adaptation to new requirements without significant cost impact. Case 3. Residential development innovation. A residential developer implemented Agile construction for a 50-unit townhome development. Rather than building all units to identical specifications, they constructed the first 5 units as prototypes with different layout configurations. Early buyers toured these units and provided feedback that influenced the design of remaining homes. This approach resulted in higher sales prices and reduced post-occupancy modification requests. Case 4. Infrastructure project management. A municipal water treatment plant upgrade used Agile principles to maintain operations during construction. The project was broken into incremental phases that could be completed without shutting down the entire facility. Each phase delivered functional improvements that could be tested and validated before proceeding to the next increment, ensuring system reliability throughout the construction process. Benefits and outcomes. Risk mitigation through early detection. Agile construction's iterative approach identifies potential problems when they're less expensive to resolve. Regular stakeholder reviews catch design issues before they become construction problems, while continuous quality testing prevents defects from compounding throughout the building process. Enhanced stakeholder satisfaction. Continuous engagement ensures final deliverables align closely with user needs and expectations. Rather than hoping the finished product meets requirements, stakeholders participate in shaping the outcome throughout construction, resulting in higher satisfaction and fewer post-occupancy modifications. Improved project predictability. While individual sprints may encounter unexpected challenges, the overall project becomes more predictable through regular retrospectives and adaptive planning. Teams develop better estimation capabilities and risk awareness, leading to more accurate budgets and schedules over time. Innovation and continuous improvement. Regular retrospectives create formal opportunities to identify and implement process improvements. Construction teams become more efficient and effective with each project, developing institutional knowledge and best practices that benefit future work. Challenges and mitigation strategies. Regulatory compliance complexity construction projects must comply with numerous codes and regulations that don't naturally accommodate iterative approaches. Successful Agile construction teams engage regulatory authorities early and often, treating inspectors as stakeholders rather than gatekeepers. They also build compliance checkpoints into sprint planning to ensure regulatory requirements are met incrementally. Traditional contracting models. Most construction contracts assume linear progression and detailed upfront specifications. Agile construction works best with collaborative delivery methods like integrated project delivery, IPD, or design-build contracts that align all parties' interests and enable shared risk and reward structures. Cultural change management. Construction industry professionals often have decades of experience with traditional approaches. Successful Agile implementation requires comprehensive change management, including training programs, pilot projects, and leadership commitment to new ways of working. Organizations typically start with smaller projects to build confidence and capability before tackling larger, more complex work. Supply chain coordination. Agile construction's iterative nature can complicate material procurement and subcontractor scheduling. Successful teams develop strategic partnerships with suppliers and subcontractors who understand and support Agile principles, often establishing framework agreements that provide flexibility while maintaining cost predictability. Agile construction represents a fundamental evolution in how the industry approaches project delivery, emphasizing collaboration, flexibility, and continuous improvement over traditional rigid planning and sequential execution. Conclusion and future vision. When properly implemented with appropriate cultural change management and supportive contracting structures, it delivers superior outcomes for all stakeholders while building organizational capability for future projects. Thank you for joining us in this episode on Agile construction. Continue your learning journey with S&P Knowledge Series. Hope you liked the presentation. Stay tuned with S&P Knowledge Series and subscribe the channel for free to get updates. For more details, contact SN Panigrahi at the below contact details.